Once we have a frame of reference, we have two big ways that we look at motion. The first one is speed, which is how fast something is going. So is it going 1 meter per second? Is it going 10 centimeters per second? Is it going 100 miles per hour? That's speed. And that's always a positive number, because even if you're going backwards, you're still going 20 miles per hour. Now, velocity is a little bit different. That's an object's speed and its direction. Speed and its direction. So going 20 meters per second north is a velocity. I might write that as 20 meters per second. And it can be positive or negative. So if I was going south instead of saying 20 meters per second south, if north is my frame of reference, I might say that I'm going negative 20 meters per second because I'm going in the opposite direction. Okay. Now, speed is useful in everyday life, but when we're talking about acceleration and how something changes, then we're really going to need to talk about velocity. So we're going to be looking today at distance time graphs. And on the x-axis, there's going to be time, which is how much time has passed. That can be 1, 2, 3, 4, 5 hours. That can be 5 seconds. That can be 5 nanoseconds. That can be 5 years. You've got distance. That can be meters, kilometers, centimeters, any amount, but it's going to increase at a steady rate. So if we haven't moved from where we started at all, we're at 0, and no time has passed, so the time is also at 0. Now, if I don't move at all and time is passing, I'm just going to stay 0 distance units away from where I started. So if I never move, my graph is going to look a lot like this. If I start to move, I'm going to be moving away from where I started, and I'm going to start to see a line as I walk away from where it started. So maybe after a few seconds, I'm 1 meter away, then I'm 2 meters away, then I'm 3 meters away, then I'm 4 meters away. Then I get my Diet Coke out of the fridge and I decide to walk back to where I was before. And I go back to where I was before. Okay? Now, a flat line shows that I'm not moving. A line with a positive slope, or going upward, shows that I am moving away from where I started. And a line going down in a distance times graph shows that I'm going back to where I started. So what if I have a line like this, and I have another line? Let's do that in a different color. I have another line like this. Okay? So if I'm looking at this, I start at 0 seconds, 0 meters from where I started. But let's say that we go to this point in time, whether it's 5 minutes, 10 minutes, whatever, it's an amount of time. I'm closer to where I started on this line, and I'm further away from where I started if I do this line, which tells us about the information that the line gives us. So our red line is steeper, meaning it's going up sharper and faster than our green line. And that means the red line is showing us a higher speed. Okay? So we have a couple ways to look at that. Let's talk through it. If I have a line that's shallow, that's a pretty low speed. If I have a line that's steep, that's showing a fast speed. If I have a line that changes, that's showing that my speed is increasing. Okay? Now, speed can't be vertical because we can't teleport. But the closer it gets to vertical, the steeper it's going to be. So this might be very slow, and this might be very, very fast. Now, it doesn't have to be going up on a distance time graph to be going fast. In fact, if I draw this line down really quickly, I went slowly away from where I started, and then I went much faster back to where I started. It's not whether the line is going up or down that tells us the speed. It's how sharply the line is going up or down. Now, if the line's flat, that means that I'm not getting further away and I'm not getting closer. So it's all the same speed. So we have a distance time graph here, and we're going to think about it this way. So we have 3 stories that might fit. Tom took his dog for a walk to the park. He set off slowly and then increased his pace. At the park, Tom turned around and walked slowly back home. Now, here's the thing. He is moving here, but which one of these lines is faster? Line 1 or line 2? Remember, we're really asking which one of these lines is steeper. And line 1 is steeper. So he didn't start slowly and then increase. He started pretty quick and slowed down. So let's check another story. Tom rode his bike east from his home up a steep hill. After a while, the slope eased off, and at the top, he raced down the other side. So this is addressing a common way that people make a mistake with this, because doesn't it look like he's going up a hill and then down a hill? Well, he isn't, because remember, this isn't his elevation. This is his distance from home. You can't tell how high above Tom is from where he started. So we're going to ignore that one. Now, Tom went for the jog. At the end of the road, he bumped into a friend and his pace slowed. So that means he was going fast, and then he slowed down when he met his friend. So we can see that that fits, and he met his friend about here. When Tom left his friend, he walked quickly back home. So look, he's going back to where he started. So the line goes down. And see, that line is still steep. Even though it's going down, that line's fast. So it fits that Tom is walking home quickly. And we can look at this all together. He starts here at 0, 0. He moves away from our frame of reference quickly, slows down, and this is as far from his house as he gets. And then he has a negative or downward slope, so that means he's going back home, and he returns home. We're going to practice with some of these graphs now. You're going to match 3 graphs, and then I'll show you the right answers. And then you're going to match 9 graphs together, including the 3 that you started with.